Hi, I am Lucy Rusek, and I teach computer science at Texas Virtual Academy in Hallsville. I've been teaching for about 17 years, with the last 10 years exclusively with computer science. My teaching philosophy is definitely grounded in the understandings by design from Wiggins and McTighe, and also from the Universal Design for Learning that I read about in CAST. I believe that meaningful learning happens when instruction is intentionally designed and it's inclusive, so excuse me, to involve all students and definitely be responsive to students' diverse needs. That means that I usually start with a clear goal, and then I work backward from there. I break it down and I use data to adjust everything. I definitely always offer students multiple ways to engage with content and show what they know. I like to build the community in my virtual environment with collaboration and peer feedback, and definitely always be consistent with my presence in the classroom. Philosophy, metacognition, and curiosity really help them grow as a person and as learners. I definitely lead by example, supporting my peers and my staff, and I'd like to contribute to the school as well. Sometimes we do PDs and they ask for an all calls, like, hey, would you like to demonstrate this? And I've definitely done that a few times. So our mission is definitely student-centered learning, equity, of course, for all students, innovation, love to try new things, and definitely our goal is to prepare our learners for the future. So my approach definitely reflects these values. I definitely use a real-world coding projects. I love to bring in anything. I'll just throw it out there. Hey kids, what's your favorite color? What's your favorite sports team? And then I'll pick that up and show them something relevant to coding. So I do that quite frequently. I differentiate instruction. I definitely make sure that I'm tapping into the kids who need the extra just a different explanation, visual learners and auditory learners. And definitely for my high students, I'd love to have them share. And once one or two shares, then they all want to share, and I definitely make it a point to praise and admire their work, because I know what it took to get to what they are showing me, so it's really awesome to be able to share that with them. I definitely continuously reflect and grow alongside my students and modeling the mindset we both want to adopt. So that is that. Ultimately, I definitely see teaching as just not delivering the content, but as nurturing potential. I'm creating future coders. So I am definitely excited to continue working together with these kids. Grades 9 through 12. I currently teach at Texas Virtual Academy at Hallsville, which is a fully online public school. It's designed to teach students foundational programming concepts using JavaScript within CodeHS. So we use CodeHS as our hands-on, and we are learning JavaScript. Students who are going to learn for this particular unit how to create interactive graphics and with and animations by working with timers and the mouse and keyboard events, conditionals, and control structures. The unit aligns to the TEKS, the Texas Essential Knowledge and Skills. There's four different ones. There's the CS12A, which is creating and displaying meaningful output using simple vector graphics, creating clearly named variables and performing operations on them, and designing interactive programming using events. There's a few others that I have definitely listed in my lesson plans, but those are the major ones that I'm trying to incorporate into this lesson. Let's see. I definitely use backward design. I used formative checkpoints and hands-on performance tasks. Let me see. I think that's that part. The unit is organized into 10 different lessons, and each one of them is building on conceptuality and technically on the previous one. We begin with an introduction to timers and animations using the set timer function, and we culminate in a summative unit quiz that covers all the event-driven programming, graphics manipulation, and basic game logic. Each lesson follows a consistent structure that supports clarity, predictability, and engagement on the course setting. The flow of the lesson is, so let's take a look at one, particularly one of the ones that I outlined. So the lesson opener starts off with a discussion questions. It's usually a short, collaborative type thing that the kids can do. So in here I have the questions, but I also have like the background, the facilitation notes. But here are the questions, and of course here are the answers that wouldn't be on the student facing, but they are here for us. And then the unique thing with Canvas is that here, let me show you as a student. Let's see if we can get into this thing. Where is it? I am. Okay, we should be able to open it so that we can annotate this and we can actually answer the questions online. So the student can actually write on the PDF or the Word doc and submit it directly. But I did find it. This is what I wanted to show you. So the way that the lesson is set up, the student can actually come in here and write on the Word doc and turn it in. So it's just a really easy way for the student to participate and get their homework done. So that is one. Let me leave student view. The second element that I wanted to highlight is the direct instruction. So the students, the flow of the lesson plan is that, hang on. The next thing that the next thing they do after the discussion questions is a video. So we see the video together, we stop at certain points, and we have some, I also have a slide presentation that matches the video. It's identical. The examples that are shown in the video are also on the slides. So the kids can have that to kind of follow along while the video is going. And then we definitely explain some new coding concepts in brief, accessible segments. So that is the direct instruction part. Then the guided practice, and that's usually the very next thing that, well, I take that back. The next thing that actually comes in this format is a formative quiz, and I'll show you what one looks like. And I have this just instruction, just basically saying, hey, this is formative. It's totally okay if you don't understand. Just, you know, this is, we're all learning. So that's one thing that I make sure the kids understand, that just, you know, this is not a high stakes quiz that's worth 1,000 points. It's 2 questions, just to kind of check the specific key skills that we were targeting with this. So that is the little quiz. And then we get into the guided practice. So the kids take the quiz, 2 questions, we talk about them, and then we move on to guided practice. So the guided practice, in the student version, when they click on the assignment, it'll actually say start assignment. And so then I have that pictured here. And then I have them here. I have this little link here, which takes them into the sandbox. And the sandbox is where any student, they don't have to have an account with CodeHS. Any student can go in here and play around in this sandbox. So then the last little bit of it is that I have specific instructions. I say first, you know, once you're in your sandbox, then I want you to click JavaScript, and I go through the instructions, the specific instructions on how to do that. Then all they really need to do is take this code that I'm providing and paste it in there, and they will have full running functioning code that we can then practice on. We can try changing values, we can mess with the functionality and kind of guess what some of the things are doing and test it for ourselves. So the guided practice just provides opportunities for for the kids to get their hands in there and take a look at, see what this code is. Then I usually give 1 or 2 of those guided practices. We usually have, depending on the unit, 1 or 2. This particular unit has 2 guided practices that do something similar, but we've changed a few little things on the guided practice. And then usually it's followed up by 1 or 2 independent assignments. And with the independent assignments, the students can, they're allowed to do peer coding to where they get together in a breakout room and they work on it together, or they can all work on it independently, and then we can all come back together and we discuss our different solutions and we share how we approach the problem and what we decided to do with that, or discussion questions. So the kids just kind of go through the same process where they have the annotation, so they can just write directly on that. At a unit-wide level, the structure definitely reflects the backward design that Wiggins and McTeague talk about. We start with clear outcomes, like being able to describe the callback function or manipulate object positions, and then we align all the lessons and assessments with those goals in mind. So that is how that. From the student perspective, the experience is designed to be interactive. It's definitely scaffolded and inclusive. Students are engaged with real coding. The challenges, they were definitely based on prior skills, and they definitely receive some support through examples and peer programming. There's visual anchors and charts, and ELL supports with formative assessments are embedded within to ensure accessibility and differentiation. For the teachers, the unit is designed to be easy to manipulate and to implement and adapt. The materials are organized in shared Google Drives. They're embedded in the Canvas and the LMS. All the lesson plans and slides and quiz links and CodeHS activities, facilitation notes are all in the same, one great place. So there's also a planning guide that outlines the timing, paired versus individual works, and lots of tips for differentiation. The Canvas limitations, they support most of the instructional needs. They embed the videos and the linking, the assignments and the collecting and the exit tickets. The platform quiz feature works pretty well, and the discussion threads. That is the one part that is a little bit limited. The discussion is a little open, and so sometimes we close that. But other than that, the paired programming logistics, the breakout rooms, they're not quite as easy to work with in this LMS as they are in our other one that we used. So that's one of them. The limited analytics on the time on task. So when the kids do the stuff on the sandbox, unless we actually had an account on CodeHS, I wouldn't be able to I can't go in there and correct their stuff and save it because it's the free version. So that's another one. 5 key lesson elements that I'd like to highlight are the lesson openers. I definitely begin with some good discussion and trying to foster some creativity and some curiosity about what we're doing. The philosophy tie-in is that it embodies my belief that we should be inclusive and inquiry-based. So definitely that. The guided practice allows for me to add the scaffolding and problem solving. The students usually can, really get in there to progress from isolated skills to some complex and creative tasks. It definitely models the problem decomposition and supports our mission to foster reliant problem solvers. We go in, we attack the problem, and we break it down into little pieces until it's a manageable thing, and then we pull it back up. And that way different students come up with different types of solutions, and they're all really great. Collaborative code review. The feedback, the kids helping each other, hey, I don't remember how to do this, and then they work in pairs, or we do it whole class, but we're collaborating together, and we're just shooting out ideas. This ties into social learning and metacognition, reinforcing beliefs that students can thrive in a respectful, collaborative environment. It definitely mirrors the workplace and cultivates digital citizenship and empathy. The embedded formative assessment lessons, the exit tickets, those are all such great tools to kind of review what we've learned and to figure out, hey, this wasn't that great, I need to reteach. So that's another great one. The philosophy tie-in on that one for the exit ticket, it's grounded in phrase emphasis on aligning assessments with the learning objectives. This shows how I use real-time data to target instructions so that I can modify anything if needed. The mission tie-in is that it ensures that every learner receives timely and individual support. And the last one that I have is the summative, of course. The final quiz gives the kids a chance to demonstrate their understanding of timers and events and conditionals and user support. Beforehand, we discuss some quiz strategies and we talk about maybe some of the things that they might not be 100% about. Promotes autonomy and mastery and reflection. And it also aligns with Wiggins and McTeague's backward design. And with the school tie-in, it supports the culture of confidence and academic excellence. The closing note for this section is together these 5 elements demonstrate how intentional planning, the collaborative practice, scaffold creativity, and equitable assessment work together in concert to bring my teaching philosophy to life.